Hi, and welcome to the first risk management installment. I'm excited to have all of you here and looking forward to a great semester where we're going to investigate not just management of risk, but the core concepts of risk. Because if we don't understand those core concepts of what a risk is and what it isn't, then it's awfully hard to manage what we don't even understand in the first place. If people are speaking past each other, one person calling something a risk when the other does not accept it as a risk, then there's no cohesion, no ability to understand what in fact it is we're trying to manage, and ultimately a futile effort where millions, if not billions of dollars are wasted every year pursuing phantoms that don't exist. So let's get started. The definition of risk is something I started thinking back on in 9/11. When that occurred, risk became very prevalent in the American psyche, and people were asking, how do I know what a risk is? And how do I know how to manage a risk? This was really the inception, at least in the popular press, of risk theory. And so I want to start with some definitions of risk today. This will be a short lecture, but one that's very important, hopefully for setting the tone for the rest of the semester. The question we have to ask ourselves is, what is a risk? Because after all, if we don't understand, then we're going to be a little bit lost when we try to manage it. Ask yourself the following question to start. What is your risk of being trampled by a non-equine horse? Well, it seems sort of silly to first ask that question, to say I was trampled by a non-equine horse, when all horses are equine. But if we stop to think about why is the question silly, another thing we might consider is to say it's impossible to be trampled by a non-equine horse. And why is it impossible? Because they don't exist. And why don't they exist? Because it's not logically possible for it to exist, and we know that things that are totally illogical and fanciful are fiction. So we'd say that a non-equine horse trampling is a logical impossibility, something that we know can't be true and can't occur, and therefore this risk doesn't exist. Notice you might have an instinct when I ask this question to put a number to it, to say the answer is 0. I want you to think about that and come back to that later, because that's going to be an important concept about probability. Why is it that we instinctively try to put a number to a risk, almost as part of the process of saying there is a risk in the first place? It's something I'm going to suggest that we need to resist initially, and I'll explain in greater detail in future lectures why we want to resist that instinct. But to return to what we're talking about here, we're talking about being trampled by a non-equine horse, and we've concluded that that is a logical impossibility, and therefore this is not a risk. Let's take another example. Consider what the risk might be of your being trampled by a horse galloping faster than the speed of light. Now, for you Star Trek fans out there, I know that you're thinking, well, the Enterprise goes faster than the speed of light, but do horses do this? Can we get a warp speed horse? And the answer is, at least in this universe as we understand it, according to Einstein's laws, the answer is no. Nothing travels faster than the speed of light that we're aware of in the universe. It is bounded in terms of how fast things can travel by the speed of light, and therefore there is no horse that can gallop faster than the speed of light. It's not impossible in the same sense that it was impossible for there to be a non-equine horse that trampled you. Instead, here we're really talking about something that's impossible because it violates the laws of nature. The fanciful phrase that philosophers use to talk about this is to say it's a nomological impossibility. Don't worry about the fancy part of it now. The easy way to say it is it's impossible because it breaks a law of nature. All right, enough with the silly play. Let's get down to something a little more serious. What is your risk of being abducted by an alien? Stop for a moment and think about that. Most of you, I hope, have never actually been abducted by an alien. In fact, we know that there are some claims of this sort, but there's no documented evidence, no credible theory that there actually are aliens to abduct. And as such, to say that we're concerned that we might be abducted by an alien seems a little weird. What is the risk of that? What I want to suggest is that this phrase, what is my risk of being abducted by an alien, is a bit misleading. Because after all, we don't actually know that you can be abducted by an alien. So when we say there's a risk of being abducted by an alien, when we don't even know that there are aliens, maybe we're sort of putting the cart before the horse. There should be something in your mind thinking about the use of the word risk and why, in fact, it might be a bit misleading in this context. After all, really what we're talking about here is a hypothesis, not a certainty. There's nothing in the laws of nature that precludes there from being aliens, but on the other hand, it's not known to occur either. And since it's not disproven, and it's not impossible in the way that a warp speed horse was impossible, but it's not known, we're sort of in this realm of what we might call uncertainty. All right, let's go to the fourth example now. What is your risk of being trampled by a horse? Now here, you really should feel a lot more comfortable. We know horses trample. We all saw the movie Ben-Hur. And we also know that this occurs not just in the past, but is likely to occur in the future. We understand the mechanics by which a horse can trample someone, and we know that there's a potential injury that can result from it. We also know there's a likelihood that that can occur. We know a lot about this. We know these have occurred in the past. And so we have a lot of evidence stored up by which we might say that there's a risk of being trampled by a horse. In other words, this is both a possibility and it is known to be a possibility. Philosophers like to call this an epistemic, a known possibility. So if we recap, there's 4 different scenarios we've come up with here. 1, a logical impossibility, being trampled by a non-equine horse. 2, a nomological impossibility, something that's not a risk because it violates laws of nature, or it violates laws of economics to the extent we have such things. 3, we know there are uncertainties. Sometimes people like to call them risks, and in a future lecture, I'm going to push back on that concept and say it's not necessarily a risk to be abducted by an alien, but rather an uncertainty. Finally, there are known risks, things like being trampled by a horse or run over by a car. We know that these occur. We know it's possible, and therefore it is a risk. All right, let's take an example now, going back to the issue of the alien situation, to see why risk is something that really, really needs to be dealt with in a clearer way than simply jumping to a number first. Because again, if I asked you to put a number on how likely it is that you would be abducted by an alien, you might come up with a number. I could do the same thing for asking you how likely is it you're going to be trampled by a horse, and you might come up with a number. Numbers seem to give us meaning and credibility when we talk about risk, but it's not always the case. Let's take an example. There's something called the Drake equation, and the Drake equation asks you to guess your alien visitation frequency. How likely is it that you are going to be visited by aliens? For this exercise, I want you to get out a piece of paper now. Stop the video, grab a piece of paper, grab a pencil. It's worth your time. I'll wait. Okay, you've got the paper now. Let's go on and talk about the Drake equation. The Drake equation is a fanciful series of variables written out as multipliers of each other. And we're going to go through, and for each of these different variables, I'm going to have you guess a number. Okay? So for each thing I ask you, write down what you think the realistic answer might be. Let's get started. The first thing in the Drake equation is to estimate the number of stars in the Milky Way. How many do you think there are? 100 billion? 3 billion? Billions and billions? Over 5 billion served? You're going to have to come up with an answer. Write down for yourself how many stars you think there are in the Milky Way. Got one? Good. Let's go on to the second issue. What fraction of those stars, assuming you've written down a number of stars in the Milky Way, what percentage of those are orbited by planets? After all, aliens have to come from planets. So what fraction of those stars are actually orbited by planets? I will give you a hint on this that current estimates are between 20 to 50%. That's a pretty big range. If you disagree with that and think it's more or less, put down the answer of what fraction you think it can be. The answer can be anywhere from 0 to 100%. Okay, you've got that now. Let's go on to the next thing. What are the average number of planets per star that are capable of sustaining life? So what we're doing now is we've said how many stars in the galaxy, what fraction of those have planets, and among those stars that have planets, how many planets on average per star? Current estimates are anywhere between 1 to 5, but you're free to say 0 to 5 trillion if you want. It's your choice. Just put down a number that you think is realistic. Okay, you've got that now. Let's go on to the next element of the Drake equation. What fraction of planets in one of those star systems is a planet in which life evolves? Okay, so we're asking among those planets per solar system, what fraction of those planets from 0% to 100% actually have life develop on them? Okay, so write down a fraction here for this. Okay, you've got that written down. Next part of the equation. I want you to estimate what percent of those inhabited planets have intelligent life. That is, life capable of actually having consciousness and perhaps even trying to communicate with outside sources, although we'll get to that in a moment. Your estimate choice here is again anywhere between 0 and 100%. So take a guess on what you think that will be. Okay, now that you've come up with that realistic estimate, we'll go on to the next one. Of those that are inhabited planets by intelligent life forms, guess the fraction that have both the ability and the desire to communicate with us. Again, you could try to estimate this. According to current estimates by NASA and others, they put it at around 10 to 20%, but I'm not putting a limit on you. You guess anywhere between 0 and 100% of those planets with intelligent life forms that have the means and the desire to communicate with us. Okay, now that you've got that, let's go on to the last element in the Drake equation. Of course, to communicate with us, there has to be an overlap. There has to be an overlap between the time that the aliens are in existence and able and willing and intending to communicate, and when we have been in existence as humans, where we have been able to receive and note that communication. Otherwise, we wouldn't know that the aliens are trying to visit us. So I want you to estimate what fraction of the planet's life during which a communicating civilization has lived has overlapped with our communicating civilization's life on our planet Earth. Come up with an estimate. Again, there's no right or wrong answer in terms of what other people think, just what you think is the right answer here. Okay, you've got a fraction for that now. What I want you to do is get a calculator, and I want you to multiply all of those numbers together that you've just calculated. So you're starting from the beginning, and for each of these 7 different variables, you've guessed a number, or a percentage, or in other words, a fraction. So I want you to multiply them together and come up with a final number. The number you estimate will be the number of communicating aliens in the galaxy who are able to send a signal that we today might get on Earth. Okay? What's your number? I've taught students before, and I've had numbers all the way from billions. In fact, in one case, the high estimate I had one year was there's 50 billion communicating alien planets anywhere in the galaxy at this time. And the low estimate, of course, is one because we all know that Michael Jackson was in fact the alien who visited us. What I hope to show you through this exercise is if you look at the high and low estimate, a low estimate could be zero, and many of you may have actually gotten the answer zero. There are no aliens that are trying to communicate with us. And some of you may have had very high frequencies in terms of the numbers of aliens that we're trying to communicate. With that sort of spectrum of guessing, how useful is this equation if this were to be a risk equation in terms of saying how risky is it that aliens are going to try to communicate with us? The answers are so broad in scope and such a wide range of what possibly could be the truth that it's almost a useless equation. And yet, as has been reported, the Drake equation may tell you more about your own views in the universe than it does about scientific fact, but the fact remains that this is the best formula that the scientific community continues to use to try to estimate how many aliens there are in the universe and how effective our methods are at trying to correspond with them. What do we learn from this today? We basically learned that this is, in fact, a very, very detailed process to understand risk. What we have to do first, before we can dig into risk, before we can start using numbers, is to think a little bit about uncertainty. We don't know that aliens are trying to communicate with us, and we don't know that aliens are trying to abduct us. To call it a risk is in some ways misleading. It's putting the cart before the horse. Until we know something's a risk, how can we call it a risk? It's not a risk, it's an uncertainty. And uncertainty is different than risk. To show you the linguistic effect difference, ask yourself the following two questions and notice what the effect on your mind is in terms of how worried you get about the scenario when I ask you about risk. What's the risk that you might be abducted by an alien? Let me ask it a different way now. What's the uncertainty that you might be abducted by an alien? In the second case, you really should be thinking more that there's not as much of a dread or a terror that comes about when I say, what's the uncertainty of an alien attack? Well, when I use the word attack, again, we're using risk language. We're going to talk about that later this semester. What is the risk of an alien abduction? In using that language, I'm giving you something that seems a little more concrete, a little more full of dread, a little more something that you might react to than in the case of using the word uncertainty. So the take-home lesson here today is that, number one, we need to differentiate between risks and uncertainties. Number two, in differentiating between risks and uncertainties, we also need to be cautious about the use of numbers. Because if we put a probability to something before we know it's a risk, we might be misleading. We'll see more about that topic in a future lecture. I'll see you next time. Thanks very much.